I have a serious problem. My ducks are hungry, and multithreading may be the only way to help them. Let me lay out the scene. These are my ducks. There are 4 of them. Using C++, let's think of each duck like a function, or an enclosed section of code. Each duck takes 2 minutes to eat from the food bowl. This is the execution time of the duck function. Now, ducks love being in rows, and so does code. If I allow my duck functions to run normally, they'll finish their meal in 8 minutes. However, I want my duck functions to be as efficient as possible. I'd prefer to arrange them in parallel and have them all eat at the same time. This reduces mealtime to 2 minutes total, which is a big improvement. Now, how is this an example of multithreading? Multithreading is a concept in computer science that allows code to execute in parallel, or concurrently. Normally, when a program executes and a function is called, nothing can run until the function is done. These functions are referred to as blocking. With multithreading, a programmer creates a thread to run a function. Threads execute functions independently of the main program, meaning both can run at the same time. We call these functions non-blocking. When we want to return the results of a thread, we use a join statement. These stop the main program until the thread is done running. If we imagine ducks 1 and 2 as the functions duck1eat and duck2eat, we can use threads to run both of these functions at the same time. Do this with all of our functions, all of our ducks, and we've just saved 6 minutes of computing time. So why multithread? Multithreading only works with multi-core processors. These allow us to divide the load of processing across multiple cores. They also allow us to reduce runtimes by processing threads in parallel. This is great for code efficiency, where fast runtimes are important. Although, multithreading doesn't always improve a program. In many cases, more threads equals more complexity, and harder to read and debug code. If one thread relies on the result of another, these threads cannot run at the same time. And more threads is not always faster. If concurrent threads access the same data, programmers must take proper precautions as well. Multithreading is pretty cool, but it's also very manual in a language like C++. In other languages, like Python, we can go a step further using something called async. Asynchronous code runs like automatic threads. Every time an async function is called, it runs independently of the rest of the code. I made a simple Discord bot with Python to demonstrate this. When I type the command riddle into the chat window, it calls the riddle function in my code, and my bot sends me a riddle and waits 10 seconds to send the answer. In the meantime, I can run other functions, such as pinging the bot for its latency or checking server stats. Because all my functions are asynchronous, the riddle function can continue to run in the background while I execute different functions on top of that. Overall, I think multithreading and async are pretty cool. Thanks for watching!